Okay, we have here today another integral from the MIT Integration Bee 2022 regular season 13. We have the integral from 0 to 1, square root 1 over x, natural log 1 over x dx. Okay, sometimes I think it's useful to just rewrite the integral and look at it a different way. So for my first step, I'm not going to change anything. I just want to look at this from kind of a different perspective. So to do this, same bounds. Let's take the 1 over x and just kind of put this in the denominator. So everything's going to be over this x here. For natural log 1 over x, you could think of that as natural log of x to the minus 1 and then take the minus 1 out. So all I'm doing here is let's just write this as minus ln x. And then from here, let's just do a u substitution on this numerator here. So we'll set u equal to minus ln x. Then we can solve for x, I think. So, well, I know we can solve for x, but let's do it. So then using log properties here, we get x is going to be equal to e to the minus u. Take a derivative on this, we get dx is going to be equal to minus e minus u du. Let's do a substitution on it. So we plug 1 in here. Natural log of 1 is just 0. Do that. Plug in 0. Natural log of 0 is minus infinity. That's why that minus is kind of nice, because then it turns this into a positive infinity. And then for this, let's actually split the numerator from the denominator. So I'll have this square root. This is just going to be square root of u here. X is going to be this, but it's still inside the square root. So we have square root e minus u, and then dx is this stuff. Take the minus sign. We'll use that to flip the bounds around so we can get the infinity up top here. Now we've got the same base here. Let me try to simplify this. So this is going to be like e minus u. This, for the square root, let's write it as 1/2. And then with exponent properties, I can kind of multiply it in like this and write that as e minus 1/2 u. Then dividing this into the numerator, we end up with e minus 1/2 u. So let me rewrite this whole thing again. And so for square root of u, let's write that as u to the 1/2 here. And then we have this stuff, e minus 1/2 u du. And now at this point, you may see where it's going, but this is starting to look a lot like the gamma function. What we need on it though is on here, this should just be a u or just a single variable. So what I want to do is a substitution just for that piece, just to clean that up and get it so we can use the gamma function on it. So then my substitution, we'll use t. So I'm going to set t equal to 1/2 u. Then I can solve for u, multiply by 2, so we have u equals 2t. du is going to be just 2 dt. So then substituting again here, updating bounds, infinity still infinity. Nothing's going to change here just because we're just multiplying a constant. Plug in 0, we get 0. Now for u, now we have 2t here. So this is going to become 2t to the 1/2. But let me separate this out. I'll put the 1/2 on the t in this 2. Let's write it as a square root of 2. And then over here, this is going to clean up to just e minus t, and then our du is going to be 2 dt. But now we have constants here and here that we can bring out front of the integral. So this is going to become 2 times square root of 2, and then everything else, we'll just rewrite it. And then one last thing here, 1/2. I can rewrite 1/2. For this, I'm just trying to get it to look like the gamma function. So for 1/2, I can write it as 3/2 minus 1. And now we have it perfectly set up. For the gamma function, our input is going to be just this right here, just this 3/2. So for all this, we'll say this is gamma of 3/2. But then before we finish it, let's get a value for this. We do have a formula we can use for the gamma function. Our formula is going to be gamma of n plus 1 is the same thing as n times gamma of n. So for gamma of 3/2, we're just reducing it by 1. This is the same property as the factorial. So what's going to happen for gamma of 3/2, we can write it as 1/2 times gamma of 1/2. But this is a good value to remember that this is the same thing as square root of pi for gamma of 1/2. So for this, what we can plug back in is going to be just square root of pi over 2. So plug this back in, and what we're left with is 2 square root of 2 times square root of pi over 2. 2's are going to cancel. Put these together. For my final solution to this, we just have square root of 2 pi. Okay, there you go. A really good one today from MIT 2022. Thanks everyone for watching. Have a good day.